Okay, I'm going to be recording a video to help people who are just getting started with R. It can be a little bit intimidating at first, and so I wanted to make this video to illustrate that it's actually really straightforward, and the commands look scary if you've never done something like this before, but it's all very, very straightforward. And if you run those commands a couple of times, you'll see that it's actually very, very easy. Okay, the project is designed to be something that is not difficult. Just as long as you type stuff in correctly, the project is going to go very easily. Okay, so here's the project on the left, and you need to open up R, which I'm assuming you have R installed. So for me, I use R quite a bit. So it's on my home menu here, and so on Windows 8, it's just right here in my own home menu. And I'm going to move it to the right so I can see this and the project simultaneously. If you have an older version of Windows, you'll have to search through the Start menu to find it. If you're on a Mac, you're sort of on your own. I don't use Mac, so you're going to have to figure out that yourself. So let's go ahead and move to the second page. And so in this project, everything's designed to be very, very straightforward. Okay, so when you see this angle bracket, that angle bracket just shows you where there's commands that you should be typing in. So that angle bracket that you see here is the same angle bracket that you see in the R prompt. So you don't need to type that in. It's already there in the R prompt, and it just tells you, hey, there's some code here that you need to type in. Okay, so here's our first code. And it says, this angle bracket says, hey, type this in. Okay, so x less than dash c with these numbers. What that says is x is going to be assigned this combination of numbers. Okay, so that's what all that means. X is going to be assigned this combination. Okay, and so we just type that into the prompt. X is going to be assigned this combination 3, 4, 4, 1, 8. Close parenthesis. And so there you go. You just hit enter, and you'll notice that it didn't tell us anything after we did that. And that's exactly what happens is if you don't type anything wrong, it won't tell you anything. And it only tells you something if you did something wrong. So if you just type in garbage, it'll tell you that you've done something wrong. So all this was just garbage, and eventually it gave me this error, right? So if you didn't type anything wrong, it won't tell you anything, right? So that's a good sign. If you typed this in and didn't get any error, then you're good. Another thing about this is that if you type something and it's still waiting for you to finish, it'll give you this plus symbol. So for example, suppose that I typed x is going to be assigned this combination 3, 4, 4, 1, and then I type enter. I haven't made an error, but I'm also not done yet. So that plus says, hey, I'm still waiting for more code. Okay, so if you get a plus, that means that what you typed in the last line is not enough, and the R prompt wants more. So here we go. I notice that I haven't finished my command. I stopped at 1, so I'll type in comma 8 parenthesis, and now it knows, okay, now I've got the rest of what I needed because I see that parenthesis, and now I've assigned x all those values. Okay, so let's go ahead and take a look at, and this is all in the project. So let's take a look at what's now in the variable x. So this line here says type in x into the prompt, and it tells you x consists of the value 3, 4, 4, 1, and 8. Okay, and so in the project you'll just write, well, the variable x has 3, 4, 4, 1, 8, and you write out exactly what the R prompt gave you in this line. Okay, so nothing to it. So the great thing about R is that it's written by statisticians for statisticians. So it has all kinds of useful statistical operations built in. So we have this list of data that's already plugged into the R prompt, and so let's compute the average of this list. And so if you do it by hand, you'll need to do that by hand in this space that's provided. But of course R has the code built into it to where we can do this without doing it by hand. So mean parentheses x says compute the mean of all the values in the variable x. So we just type that in, and it gives us 4. So the mean of all these values was 4. Okay. We also have standard deviation. So if you take the standard deviation by hand, it's that long formula with the square root of the sum of those squared values, and you'll need to look it up if that's not making sense. So if you know sample standard deviation, do that here. If you don't remember the formula for sample standard deviation, look it up and compute it by hand in this space. Okay. Now the nice thing about R is that we have x loaded, so if we want the standard deviation, we just type that in, SD of x, and it tells us the standard deviation is 2.55, basically, right? So you'll answer, what is the standard deviation? You'll put it right there, okay? So it also has a lot of graphical features. So if you do plot x, it opens up this plot here, and so what this does is the first value had a value of 3. The second value in that list was a 4. The third value in that list was a 4. The fourth value was a 1, and the fifth value was an 8. So that's all that plot function does, is it lists off the item, the first, second, third, fourth, and fifth item, and it tells you the value that that item had. Okay. So now, it says here, let's define a new vector with some quiz scores. And this is actual data. This is data from when I was teaching at UCSC, and I had a quiz this week, and these were the scores. The quiz was worth, I believe, 25 points. I can't remember. But I think the quiz was worth 25 points, and so here's actual raw data from my students. Okay, so what this says, it says, I'm going to assign the variable y this list of quiz data. Okay, so let's go ahead and type this in, and you want to do it exactly the way you see it on the screen. And if you make any mistakes, you need to redo it, which is what is sort of turns this into a project. It's you're not going to get through this without making mistakes, and so you will have to go back and rewrite stuff as you go, and delete variables and stuff that you enter incorrectly. So it is a bit of a project, but it's very easy. Okay, so let's suppose that we want to enter this data into the variable y. We would do that just by doing y gets assigned this combination 17, 19, 16, 7, let's see, 20, 19.5, so on and so forth, right? Okay, so we entered in all those quiz scores, and I've been, I've typed a lot of numbers in for the type of work that I do, so I'm pretty accurate when it comes to typing numbers. A lot of you guys, though, may have made a mistake, and so suppose that you typed in a mistake where you did something like y is going to be assigned this combination 17, 19, 16, 7, 20, 19, and then instead of doing 19.5, suppose you did 19 comma 5, and then you did 20, 25, and so on. Well, if you make a mistake like that, what you'll need to do is hit the up arrow. So when you hit the up arrow, it'll bring your previous entry back up, and then you can go back and you can correct the mistake that you made. So instead of 19 comma 5, like we accidentally entered, we want 19.5. So you'll change that, 19.5, and then you'd go on and type the rest of your data so that eventually you'd have the list entered correctly like you see here. Then once you have that, hit enter again, and then you've got your Y properly loaded. Okay, so there's our Y. And suppose that we want to get a nice graphical interpretation of this data. Hist of Y just means give me a histogram. And incidentally, that also gives us a way of checking our data input, because if we get some weird random value in this histogram, that may be a sign that we made a mistake. Okay, so hist of Y gives us, in this other window here, a histogram. So you see the scores are stacked up pretty high. You know, there's a couple stragglers down below, but most of the scores are pretty high. Suppose that in this data set, maybe we accidentally typed in, instead of 14.5, maybe we forgot that period. And suppose that we did hist of Y. That'll show up as an error. And so you'll see that most of the scores are way down here, and then there's this one weird one. That's because we typed in an error. Okay. So whenever you do that histogram, be on the lookout for any weirdness like that. In our case, everything got typed in appropriately, and so our histogram shows up as expected. Okay, so there's our histogram. So draw a rough sketch of the histogram, and then answer, does this appear to be normally distributed? And obviously in this case, it doesn't really appear to be normally distributed based on this graph. Okay, so draw in that sketch and answer the question and explain why you're answering the way you are. So does it appear to be normally distributed? Why or why not? Okay, so this graph was given to us by default. R just said, okay, I'm going to give you 4 classes for this graph, but we can certainly change the number of classes if we want. So hist has different options that you can plug into it that'll change the graph to make it look different from the default. Okay, so you just type that in, and you'll see I made a mistake there, so luckily I caught it before I hit enter. Go back, correct that mistake. Okay, and then you hit enter, and now it breaks it down into much finer classes. So it's you know, the default didn't really describe the data set quite right, so we had to go and change the default settings that R gave us to where now it's describing the data set much more clearly. You're right, it describes it a lot better for our purposes. So you'll type that in, you'll write that in, and you know, describe the graph, and you know, so you just very carefully follow the directions. Draw a quick sketch of the graph, include the axes and the values listed on the axes. So just follow directions basically. And then you'll notice that the previous histogram and this histogram, they were the same data set. So the previous histogram didn't really look normal. This histogram, you'll notice, looks much more normal. Okay, so that's telling you something. It tells you that the way you set up your graphs changes the interpretation of the data set. So the first one, we wouldn't say that's normally distributed, but if we change the histogram to where we have more classes, now it looks like a normal distribution. So that's what that's meant to portray to you, is that you really do have to pay attention to how these graphs get set up, because it changes the interpretation. Okay, and we see that this thing's just an outlier. The rest of this is basically normal. So moving on, you can see we're already on page 5. So you can see this is going to go pretty quick. You just type stuff in, interpret, write stuff into the project, and you know, there's not a whole lot of difficult. There's nothing difficult about the project. Okay, so just as a little recap, let's go ahead and recap just these very basic operations. We now know a few basic commands for entering data and for viewing data. Suppose we want to assign the vector x to have the values 4, 7, 12, 1, 3, 8, 6, 5. What command would we enter into the prompt? So you'll write that in to the project, and once you've done that, type that into R, which I won't do. Type that into R and then find the mean and find the standard deviation and write those values in so that I know that you've done it successfully. Okay? Now in R, these lists of data, they're given a special name, and they're called a vector. So all a vector is just a list of numbers. So to assign a variable a vector, you're just doing that x is assigned to this combination thing. Okay? So let's go and in this section here, you are supposed to assign this data to a vector x, and now I guess I'm going to have to do that real quick. So x is going to be assigned to this combination 4, 7, 12, 1, 3, 8, 6, and 5. Okay, so there we go. X gets assigned to that list of data. Now, we did some operations up here, which I'm not going to do because you're supposed to do them. But whenever you perform operations, this list doesn't really change. So maybe you did some calculations with x. X is not going to change until you tell it to change, okay? So when you type in x, it's still going to give you this same list back, okay? Let's try something different. So let's type in x plus 2. And it gives this list of values. And you're supposed to describe in words what R has done. So the original list was this list here, 4, 7, 12, 1, 3, 8, 6, 5. How is this list related to this list? And you'll have to answer that on your own, but it's pretty clear what's happened, right? Now type in x. Oops. So now just type in x into R, and you'll notice that it just gave us that same list back. Okay. So this is the original set of values, and so even though we computed x plus 2, it still gave us the originals back when we typed in x. And the thing about this is that x plus 2 that we did here, it wasn't assigned anywhere. It wasn't stored anywhere. R just took x plus 2 and it did the computation, and it didn't store it anywhere. So if you want to store that computation, you have to type in something different. So this y assigned x plus 2, that's going to take that previous calculation, and now it'll store it in the variable y. So if you hit y, enter, now it tells you the value of x plus 2. Okay? So I'll let you guys work through these on your own. And in this following set of computations, you're going to take that same quiz data, and you're going to compute mean, standard deviation, and you're also going to compute z-scores for all of these quizzes, which may sound like a big task, but R has functionality to make it all go very quick. Okay? So very carefully follow the steps that are shown here. You'll need to enter in the quiz data into the variable p. And there, let me show you a shortcut for that. We already entered that quiz data in earlier. So if you go back up to where that quiz data was entered, I'm just going to choose the list where it was all entered incorrectly. So let's see, these all look correct here. Just go hit the up arrow until you find the list that was entered correctly, and then just change the variable. We don't want it to be entered into the variable y, we want it stored in the variable p, because that's what the directions tell us. P is going to get assigned this combination of quiz scores, okay? And now you've got P loaded. Now, run through all these steps, compute the values, and then just write out the values as requested, okay? Moving on, section 1.2. The R environment has, tons of statistical plots that we can do. And if you think back to chapter 6, one thing we do with data on a regular basis is study whether or not it's normal. And we talked about normal quantile plots. Those are very difficult to set up by hand, but R has them built in. So this code here will give you a normal quantile plot for that previous quiz score data. So let's go ahead and plug that in. QQ norm of P, and then the plot window gives you this normal quantile plot. So go ahead and read through all this, interpret the normal quantile plot. Okay. This command is going to load some normal data, okay? So our norm of 1,000 loads 1,000 normally distributed data points, okay? And let's go ahead and type that in. Random is going to be assigned our norm 1,000, and that says take 1,000 normal data points and plug them into this variable that we're going to call random. QQ norm of random then says give me a normal quantile plot for that data, and you'll see that it's very, very straight, very linear, and that normal quantile plot then indicates that that really is a normal variable. So just keep going through these commands here. They're all very straightforward, and just keep typing in the code and interpreting the results as we've been doing here.